So I was like, hey, all right, let's take that. And so I thought that, hey, since we have all this water surrounding that is deserts and the temperature in deserts is slowly increasing, why not couple these things, put them together, and build something? And so I did some research and I found this experiment this guy did where he used the sun's temperature to heat up water, desalinate it, turn it into steam, and then run a turbine using it. Here's a video of him, talking about it and showing you it.
This one's been running for an hour, and I haven't had to readjust the trough. That's one advantage to a trough mirror. If you set your trough on a west to east pattern, the sun's going to track across the sky, and that beam's going to stay pretty much in place from about 11 a.m. through about 3 or 4 p.m. Now, you can use a heliostat to track the sun to get the early morning and the late afternoon as well, but for basic heating, this is just really amazing. I'm going to undo this. You can see that water is just extremely hot. I've tested this, and this will actually do about a gallon a minute at 140 degrees, so that's pretty good. It'll do a quarter of a gallon a minute at about 190 to 195 degrees. So that is a lot of heat for that. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos.
The end product of this process is electricity and desalinated water, which is awesome because if you think about it, if we can have electricity and clean water in a desert, we can then couple this with a system like an automated farming system, basically robots that run based on this electricity that we just made, couple that with the water that we just have, we can build systems, basically robots that can farm for us. And so here's some examples of automated farming systems.
This is AeroFarms, a massive indoor vertical farm in Newark, New Jersey.
Our mission is to build farms in cities all over the world so people have access to fresh, great tasting, highly nutritious food.
Crops are stacked more than 30 feet high inside this 30,000 square foot space. They're grown using aeroponic technology.
Typically in indoor growing, the roots sit in water and one tries to oxygenate the water. Our key inventor realized that if we missed nutrition to the root structure, then the roots have a better oxygenation.
AeroFarms says the root misting system allows them to use 95% less water than a regular field farm. They also use no pesticides or herbicides. Instead of soil, plants are grown in reusable cloth made from recycled plastic. And instead of the sun, there are rows and rows of specialized LED lighting.
This is also another company I was trying to build, an automated farming system company, but I'll get into those later. But for now, I'm trying to show you the different tools we can use to solve global warming. So the last tool is 3D printing. 3D printing, is from aerospace engineering to dental industry to locomotive. But the cool thing about 3D printing is that there's a company in China that 3D printed 10 houses in 24 hours. And this was 5 years ago. All this research I did was 5 years ago. And so fast forward to now, we can do some crazy stuff. But here's a video showing you the, company that 3D printed 10 houses in 24 hours.
These buildings behind me were not built in the normal fashion, but were actually printed out by a 3D printer.